Hi lads, I'm just going to explain to you a little bit about meander formation. Now, as you know, a river is always striving to find the path of least resistance. And so in our example A here, we have a load of sediment perhaps in this area here. The river has therefore moved onto the outside bend to avoid it, to find that path of least resistance. Hence it's moved to the outside. Due to the centripetal force, it's then been forced back to the other bend onto the outside. And you can see the red line there demonstrating the Thalweg line. As time passes, more and more erosion will occur on these outside bends, developing it into a nice broad meander as we have here in section B. Now in your exam, rather than saying erosion, the terms that you want to be talking about are things like hydraulic action, abrasion and corrosion, all pushing these banks wider and wider. And where erosion has occurred on that outside bend, you will end up generating river cliffs, which is often where you end up with overhangs. On the outside bends here, you'll end up with your river cliffs. Whereas on the inside, you have much slower flow. And therefore, if you have slower flow, a river will have less energy, and therefore deposition will occur. And so you will end up with lots of areas depositing their material on the inside of all the bends, creating a feature known as a point bar or a slip-off slope. And as you can see, that's represented by little dotted areas on diagram B. Now what happens in the flow is that a river flow, or the way that water moves, is in a helicoidal motion, which means it's in a corkscrew sort of fashion. And it therefore erodes material from the outside bend, and it moves it onto the inside bend for deposition to occur. So erosion occurs on the outside bend, it then carries that material onto the inside of the next meander bend, and that's due to the helicoidal corkscrew flow of the water. Now over time, this whole meander will start to migrate its way downstream, and the bends will start to develop further and further down due to erosion, and that is known as meander migration. Okay, and you end up with what's known as a bluff line right down the outside of the meander, and the areas in between are known as your floodplains, which generally are deposited with rich alluvium and can be incredibly fertile. So just to summarise so far, a river tries to follow the path of least resistance, and that's your Thalweg line being the fastest flow. You also need to remember the term centripetal force, which pushes the water to the outside bend. You also need to know that here, on the outsides of the bends here, you're going to have a river cliff. On the inside here, you're going to have a point bar. You're going to have meander migration occurring here, meander migration. You're going to end up with your floodplain, which is going to be in these areas here, and you're also going to end up with a bluff line, which you can see here. If the meander becomes even more extreme or even more sinuous, you can end up creating an oxbow lake, which is what we've got just here. Now this has occurred because a river has, the neck of the meander has become really narrow, as you can see just across here, and the power of that water will erode right across the neck, breaking off and leaving behind your oxbow lake. Now oxbow lakes are really good for biodiversity because it provides a different habitat for wildlife. What eventually will end, because there is no water running into the oxbow lake, it will eventually dry out and become a meander scar. So that, I think, is essentially your meanders, and hopefully it's all quite clear and well explained. Cheers.